we're going to use Kirchhoff's rules to solve a circuit. That is, we're given a circuit with two sources of voltage. Could you put that away?
Yeah.
And then 3 resistors in it. But unlike the last example we did, this isn't just one loop. This is more complicated. We've got 3 different currents in this circuit, and that's what we want to find. So we want to find the 3 currents in the 3 different branches here. We've got this branch right here. We've got this branch, this wire, and this. And they all have different currents. And so to solve a circuit means to find all what those currents are. And if you find those currents, then you can figure out how much energy is coming out of these resistors, what the power is, and all that sort of thing. So that's what we mean by solving a circuit. So let's solve it. Well, the first thing you need to do is to name the currents and stick with those names, and then choose the direction of flow for those currents and stick with those through the whole thing. It's very easy to make a mistake on these problems. You have to be very meticulous, very, very careful at each step. Now this is an example in the textbook, so I'm going to stick with their convention, but it's arbitrary. First thing you need to do is pick a junction. Now I'm going to pick this one. Could I have picked this one? Absolutely. And then you need to pick the direction of current flow and name them. So what the book did, and what I'm going to do just to stay consistent with it, is we're going to name this current I1. So the current that flows through this branch, a certain number of coulombs per second, is going to flow through here. We're going to call that current I1. And then we're going to call this current I2. So everywhere in this branch, flowing from here all the way around here, this is all I2. Well, if I've got 2 currents flowing in, I better have some current flowing out. We'll call that I3. Now, this gives us an equation that we can use to solve for the currents, or at least it gets us started. We're going to use the junction rule to come up with a formula. I'm going to come up with an equation. I1 is coming in. So anything that's going to come into the junction, it's adding charge to the junction, I'm going to make that positive. I1 plus I2, because that's coming in. But I3 is leaving the junction, so I'm going to make that negative. I'm going to leave some space here, equals 0. Now I could have written it down a little bit differently. I could say the current into a junction has to be equal to the current coming out of a junction. Does that make sense? You know, you got stuff flowing in, you have to have the same amount of stuff flowing out. Okay, this isn't a tank or anything. This is just, think of it like where 2 hoses come together, and then you got 1 hose after that. You know, you got water flowing in through here. You got to have the same amount of water flowing out. Okay? So that's pretty easy. That's the junction rule. It's the easiest one. But look what I got. I got 1 equation, but how many unknowns do I have? 1, 2, 3 unknowns. How am I going to solve for 3 unknowns? What do I need to solve for 3 unknowns? I need 3 equations, 3 independent equations. So I'm going to now use the loop rules. And I'm going to choose 2 loops, and it doesn't matter which loops you use. You can use the outside loop, you can use the top loop, you can use the bottom loop, you can go clockwise, or you can go counterclockwise. It doesn't matter. If you're consistent, if you use all these little rules properly, you will get the right answer. All right, so let's do the top loop. And let's go around in a circle like this. So think of Voltage Man. Voltage Man is now going to walk around in loops around this circuit, measuring the voltage changes as we go. And of course, Voltage Man will end up where he starts. So what's the total voltage drop going to be if you go in a complete circle? It's going to be 0. So we're going to have an equals 0 over here. So let's start here, and we're going to walk along here. We're going to do this top loop. And then I get to this resistor. Now, with resistors, you have to think about what direction the current is flowing. Am I going with the current, or am I going against the current? Well, I2, it flows down like this, which means that over here it flows this way, which means over here it flows up. So if I start here and walk this way, clockwise around this loop, I'm going with the current. Think of a resistor in your imagination as a little waterfall. And so here the water's up high, and then it goes down this little waterfall to the bottom of the waterfall. You've lost energy. You've lost potential energy. So, and in the process, you're giving up energy to the environment. A resistor releases energy in the environment in the form of heat or light or work. Somehow, though. So I'm going to have a voltage drop here, a negative change in voltage. And I'm going to call this 4 minus 4I2. Now look where I'm putting it in my equation. I'm putting it here, underneath this I2. I'm going to line everything up, make it look nice and neat. So I've lost 4 ohms time. Remember, delta V, and I should, equals IR, right? Current times resistance. Now this is one of the few times I'm going to leave units out of my equation as I solve it, because this gets really cluttered and I want to keep it nice and clean. So make sure you understand, what units you're using and all that as you go through this. Minus 4I2. This is R times I. Yeah, usually you go I times R. It doesn't matter. I'm going to go R times I. Because think of this as being a coefficient in front of this unknown. Then I go doop-de-doop-de-doop-de-doop-de-doop-de-doop. Now I'm going to jump across this electric cell or battery. Boop. Is it a voltage? When I go from here to here, am I gaining voltage or am I losing voltage? I'm losing voltage. Why? Because I'm going against the battery. Think of what this thing does right here. It says, hey, look, everything on this side is going to be 14 volts higher in voltage than everything on this side. The battery boosts your voltage up from the negative side to the positive side. Well, we're going the opposite direction. Now, think of Voltage Man walking around the circuit. What does he have to do? He has to step down in voltage to go from here across there. Okay? Drops in voltage. So that's going to be minus 14 volts. I'm going to put it kind of up here because I'm anticipating something later. Then I'm going to go ba-doop, 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 ba-doop. Now I started over here. Now I'm going to go over here. But now look, I'm swimming against the current. And I've come to this little waterfall. I'm like a salmon swimming upstream, okay? Have you ever seen a salmon swim upstream and they have to go up a waterfall? They have to jump up. This is a little waterfall, but the waterfall's going this way. We're going to go against the waterfall. We're going to jump up in voltage. So we're going to go up positive 6I1. And then I get over here again. Look at this 10 volt battery here. I'm going to step down in voltage, which means I'm going to lose another 10 volts. So I lost, when I went over here, it was plus, or when it was minus 14 volts, and I go down here, minus 10 volts. That's minus what? 24 volts. So over here, I'm going to put minus 24 volts. So I've got an I1 and I've got an I2. Notice what I don't have. In this loop, there's no I3, is there? So I'm just going to put, I'm just going to leave it blank like that. Yes?
So you lost 10 volts on that 10 volt battery because you went from the positive terminal to the negative.
Exactly. I'm going against the battery. And, it's going to work out. Now, what loop do we want to use next? Well, I don't care. Which one do you want to use? What do you want to use? You want to go the outside loop, or do you want to do this lower loop? You tell me. The lower loop. Do you want to go clockwise or counterclockwise?
We go clockwise.
Clockwise, okay. So let's start here, and we're going to go in a loop like this. So now I'm straying from the book, I think. So now I'm going to be all screwed up. All right, so here we go. We're going to start here. Totally new equation. Doop 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 doop. He actually sings as he goes. Oh, boom! Positive 10 volts, right? You see, I'm going with the battery. I have to step up in voltage. All right, so that's going to be plus 10 volts. And I'm looking in here. There's no other batteries in here, so this is it. Okay, so now I get to this. I'm going to go over here. Oh, I'm going with the current. I'm going down a little waterfall. I'm dropping in voltage. It's going to be minus 6I1. And then I go down here. I'm going with the current, minus 2I3. And now I'm back to where I started. Okay, let's do it again.
On the previous equation, you have plus 6I1, and that's because what?
Well, when I made, and the question is, why is this positive 6I1 and this negative 6I1? Look at the direction voltage man was walking. In this top loop, which is what we used to create this equation, when we got here, we went against the current. So we were here, and then we took a turn. And then we're swimming against I1, and we have to jump up this little waterfall of a resistor.
And like the direction of I1 was arbitrarily chosen.
Yeah. Now, by the way, I1 was arbitrarily chosen, but once you've chosen it, you have to stick with it through the whole problem. And by the way, what happens if you choose the wrong direction for a current?
It's not so bad.
It's not so bad. What will happen is that when you get the answer, it'll come out negative. And you'll say, oh, okay, it's flowing to the left instead of to the right in that branch. No problem.
And then so you chose that I1 would go that direction. And then in this second, on the bottom loop, you're now going with
Yeah, I'm going the opposite direction. In this bottom...
And so since you're going with the current, that's why it's negative?
Exactly.
Okay.
Because, yeah. So as the current flows through here, it releases some of its energy to the environment. And so you have less energy down here than you had up here. There's a loss of potential. All right, so now look what we've got here. We've got an equation, or 3 equations and 3 unknowns. Yes?
So if we had chosen to go counterclockwise on this one, would I2
No. On the bottom loop?
No, on the top.
On the top, no. If we had gone counterclockwise instead, this equation would be exactly the same if you multiply everything by -1. If you go clockwise versus counterclockwise, the only thing different, it's the same equation, except you've multiplied both sides of the equation by -1. Instead of going against the battery, we would have been going with the battery. So this would have been positive 24 volts. Okay? And instead of this being negative -4I2, since we're going against I2, we're swimming upstream, so it would have been a voltage gain as we went from here to here. Okay? So think about it. Now, there's two ways you can go from here. You guys have all your fancy pants calculators that can solve 3 equations and 3 unknowns. I highly recommend you learn how to do that. You just look it up. There's tons of YouTube videos on how to do it. You all have different calculators. It drives me crazy. You have all these wonderful calculators. Learn how to use them. It's worth your time to learn how to use them. Let me show you what you're going to end up with. I'm going to draw a matrix like this, and I'm going to look at I1, I2, and I3. And what I'm going to put in here are the coefficients that go in front of it. 1, 1, -1. Then I'm going to look over here. 6, -4, and in front of I3, 0. There is no coefficient in front of or 0 is the coefficient in front of I3 because there's no current 3. And then over here, -6, 0, -2. Now what about these guys? Well, when it's your calculator, and I'm running out of room here, you put these on the other side. So this is just 0. There's nothing over here. This is -24 over here. You end up putting it over here. And then this right here is 10. Put it on the other side, it's -10. Usually this is the way it's set up on a calculator. You'll type in these coefficients, and then it wants this. This is called a column matrix right here. It wants this, and then it will give you this. Now, this is a little bit of matrix math, and they don't teach that in AMA, but you don't actually need to do this to solve the problem. I'm going to solve it manually here in a second, but it's pretty cool. The way you reconstruct this, if you're given this, is you go this times this plus this times this plus this times this equals that. Then you do the second row. This times this plus this times this plus this times this equals that. And then this times this plus this times this plus this, I'm sorry, I'm doing it wrong. This times this plus this times this plus this times this equals that. Okay. It's kind of cool. But there is a way for you to do it on your calculator. Here's what you are allowed to do on the test. You're going to have a problem very similar to this on the exam. And what I'm going to do is I'm going to grade these, and I'm going to give you credit for the right answer. But the arithmetic in between isn't worth any points. What is worth points is setting these equations up and then getting the right answer from them. Learn how to use your calculator. Okay, because now if you don't learn how to use your calculator to solve 3 equations and 3 unknowns, then you're going to do it like we did back in the 80s. Okay, you're going to solve it by hand. Now here's how you do it when you solve it by hand. Usually what I do is I take the first and second equation to eliminate what's missing in the third equation. Now what's missing in this third equation? I2 is missing. Do you see this third equation right here? And by the way, this is tedious. This is the first equation. I'll call this the second equation. This is the third equation that I'm using. Now I notice, okay, there's no I2 in this. So what I'm going to do is I'm going to multiply equation 1 by something so that when I add equation 1 plus equation 2, I2 will go away. So just watch. I'm going to multiply this by 4. I'm going to multiply equation 1 by 4. So I get 4I1 plus 4I2 minus I3 equals 0. And then I'm going to add that to 6I1 minus 4I2 minus 24 equals 0. And this is why, by the way, I often make mistakes when I work through these problems because it's so hard to do. So this is 10I1, 0I2, minus I3, minus 24 volts equals 0. Now look what I've done. I'm going to call this equation 4. Look what I've done. I've eliminated I2 from this equation, but this equation is independent from this, and it has the same two unknowns. So now what I'm going to do is I'm going to multiply this by something so that when I add it to this, to equation 3, I'm going to eliminate either I1 or I2. And I look at what's easiest to do. Well, if I multiply this by negative 2 and then add it to this, I will eliminate I3. So let's multiply this equation by negative 2. Negative 20I1.
Shouldn't it be 4I3? So you multiply the equation 1 by 4.
Well, look, I have a negative 2I3 here. If I multiply this by negative 2, I'll have a positive 2I3 here, and then when I add them together, I3 will go away.
No, in equation 1.
Did I make a mistake?
Equation 1, it should be 4I1 plus 4I2 minus 4I3.
Oh, thank you. See, and this is, yes, thank you so much. 4I3. So this should be minus, ooh, look at that, 4I3. Thank you. Yeah, and you know what? This is why I'm bad at this. I'm bad at solving these problems because I'm very prone to making little mistakes like that. That's why a calculator, if you are prone like I am to making little meticulous mistakes like this, you learn how to use your calculator. So, okay, thank you, because I would have wasted this whole video. All right, now this is negative 20 I1. And so what do I want to do? I want to not do that anymore, right? I want to get rid of, well, I'll tell you what, I'll just multiply this by negative 2. I'll multiply equation 3 by negative 2. So that's going to be 12I1. Is that right? And then negative 2 times negative 2 is 4I3. And then negative 2 times 10 is negative 20 equals 0. Did I do that right? Yeah, and please help me out here. All right, and then I'm going to add these two together. So I get 22I1. I've eliminated I3. I've got negative 44 equals 0. And now I've solved for one of the currents. That is I1 equals, well, put 44 on the other side, divide by 22, I get 2. So I1 is 2 amps. Woohoo! Well, if I know I1 is 2 amps, I can plug in here to get, well, if I1 is 2 amps, I can plug it into equation 3. So here's equation 3 again. And I get negative 6 times 2 is negative 12 volts. Minus 2I3 plus 10 equals 0. So I'm going to have negative 12 plus 10, that's 2. I'm going to subtract 2 to the other side and divide by negative 2. So I get I3 equals 1 amp. Is that right? Is it negative 1? Okay, because I'm going to, yeah, negative 1. Thank you. All right, and now that I have I3, or actually, I'm going to plug in I1 into equation 6. So I have 6 times 2 minus 4I2 minus 24 equals 0. So I'm going to have, well, 12 minus 24 is negative 12. So I'm going to add negative 12 to the other side. So I get negative 4I2 equals, am I still on screen? No, tell me if I'm getting close. Equals 12. So I2 is equal to negative 3 amps. Is that right? Now, I can test to see if I'm correct by using equation 1. Let's see. I've got 2 amps. So let's look at equation 1. I've got 2 amps minus 3 amps minus, and then I3 is negative 1 amp. Does that equal 0? 2 minus 3 is negative 1, minus negative 1 is 0. Woohoo! Oh, thank you. So my answers are, I1 equals 2 amps, I2 equals negative 3 amps, and then I3 equals negative 1 amp. And that's my answer based on the, let me zoom all the way out here so you can see the lamp. Okay, based on the currents I arbitrarily chose. I didn't choose very well, did I? I mean, like two out of 3 of the currents turned out to be negative, which means I guessed wrong, guessed the wrong direction. But that's all right. That's going to happen. Okay, but where's this is all arithmetic, which we're all prone to make errors with. It's very hard to do. That's why on the test, getting these right is going to be worth, I don't know, a point. What I'm going to give you 9 out of 10 is getting these right, getting these equations right. If you mess up between here and here, it's going to be not worth that much. But so learn to use those calculators, though. It's useful to learn how to use. Yeah. All right.